Okay, so we're starting to sort of do the review process for our next test. We got a few problems left on area, but we already talked about area the other day, so this is not really new. But we got some good practice problems we can do in this section. So if I were going to ask you to find an area, now you got two different ways you can do it. Let's say I had a couple sides. This one's 8 and this one's 7, and this angle looks a little less than 90, maybe like 70 degrees. Do you get that that would form a triangle if I wanted to connect those two? And then that would have an area, right? Would you use the right formula and figure out that area? The heroes would not be a good choice here. Heroes has a semi-perimeter, but that would take forever because you have to find the third side first. So what is that formula? Area of this triangle then, 1/2 what? AB sine of C. And since we only have one angle, it made it really easy. You could figure out, oh, you must be talking about sine of 70 then. Go ahead and do that. Figure out that area. Next, the law of cosines would allow you to figure out how long that other side is. I'd like you to do that. I'm going to call it Q. Please figure out how long Q is and the area of this triangle. And then we'll talk through heroes, the new one, how that's used. Pause for a second while you're trying. All right, so tell me, which did you figure out first? I'm curious. Did you figure out the side, Q, or did you figure out the area? Okay. Sure, I understand. And then, and you can do it in any order, doesn't matter. So the area of this puppy, 1/2 AB sine C, when you multiplied that all out, what did you get? 26.31. Can anybody verify that number other than the rounding? Okay, good. Yes, I'm pretty much everybody's agreeing with you. Then, how about the Q part? How do you do that? Is there a formula you use? Excellent. What is it? Can you read it to me? I'll just, the general form of the formula would be good to start with. Cosine, actually. That's all right. It happens all the time. I do it myself. So, because the law of sines, or sorry, this area one has sine in it, and it's so much like it. You know, A, B, and then oh. All right, and then equals what? Perfect. When you stuck those numbers in it, by the way, this could be A or B. It doesn't matter. That was obviously the cosine of that angle, and it will only figure out the side across from that angle. So that's one of the keys with cosines is you got to set it up so you are finding the side across from the angle. If we had wanted to find this side, it wouldn't work. We'd have to set it up completely differently. All right, what did you get? Final answer? Inverse cosine probably it. No, wait, we already knew that. So cosine, so it's square root at the end, and C equaled, raise your hand if you had 8.64 for that other side. Okay, good. Then I think you understand law of cosines. Law of sines is pretty easy. We should probably review it for a second, though. How could we now use law of sines to figure out this little angle up here? Well, set it up. Go ahead and just set it up. I don't even need you to solve it. Just set it up right so you can find the green angle. Otherwise, you don't know how to use law of sines. I'll pause while you give that a try. Okay. I'm going to set it up with law of sines. I'm going to call it, does it matter? Does the law of sines picky about which one's which? No, it does not care. So I'm going to call this A. And then the side across from it's little a, etc. All right, so I'm going to do sine of some angle I don't know. I'll call it theta. Over 7 is equal to, then I really need to use these guys because that's the angle and side that I have. And I'm going to say sine of 70 over, and then that side we figured out was right here. And we figured out that that was 8.64. If that's what you set up, then you probably would have done it right. You had to figure out this, and you times it by 7. And then how do you undo so that sine's alone, or the theta's alone? Inverse sine. At the end, you do inverse sine. And dice of destiny, let's see what you got. Row 4, person 4. Let's That's you. Can you say it one more time? All right. Can anybody verify 49.58 degrees, maybe off by a smidge on rounding? Okay, good. Then, you know law of sines, law of cosines. You know how to find the area in that one way. How about the new way to find the area? That's where I give you all three sides. Now, could you use all three sides, 5, 6, and 7, to figure out one of the angles and then do the area that way? Yes, you could. You could use law of cosines and figure out one of the sides. You'd have to do inverse cosine at the end. But it wouldn't be that hard to figure out one of the sides. But how about going directly? Let's just do the semi-perimeter of this thing. 5 and 6 makes 11 plus 7 is 18, so I'd use 18 as my S. Oh, what's that actually? 9. Semi-perimeter is 18 divided by 2. Semi means half of. So our S is 9. Use that and figure out use that and figure out the area using Hero's law. Square root of a whole bunch of things. I'll pause for a minute while you try that. You probably need a calculator at some point because you're going to do square root of this nasty number at the end. All right, excellent. We get to learn it together. So that formula is S times, and then were you here the day we learned the formula, or were you just absent, or? All right, so if we start with S, and we times it by 3 things, hint, there's 3 sides. And it involves semi-perimeter a lot. Let's take a shot at what it is. I'm going to call it A, and then the semi-perimeter minus B, and then the semi-perimeter minus. Awesome. So then it's square root of, and in this case, what is our S? 9. Semi-perimeter is 9. Times, help me out. Doesn't matter what order, so. Minus. S minus 5, which would be 9 minus 5, which would be 4. Okay. And then 9 minus 6, which would be, and then 9 minus 7, which would be 2. And then you can do this in any order you want, but you're going to multiply that all out. Help me, save me some time. Square root of what? 216? And then grab a calculator and type that puppy in. See what you get. I'll let her finish it because she's capable. All right, 14 point, should we round it to 7? About 14.7 will be the area of that puppy. All right. Any questions about how to use Heroes? All right. So at the beginning, we started this whole thing. We taught you about triangles, and if you had one side and one angle, you could pretty much figure out everything. Now you're seeing that if you have all the sides, you could pretty much figure out everything. Because once you have all the sides, you can figure out the angles. All right? And even in a right triangle, you can get away with just having 2 sides. Just want to do one like that, because if you still don't get this, this is huge. This is a 5, 12, 13 triangle. Okay, if that's going to be 5, and that's going to be 13, and you know I already said it, the other side's 12. But my question is, what's this angle right here? Just take a second. We're going to see if anybody still doesn't remember how to do that. Find the angle. This is a right triangle. Oh, I hope that one felt really easy. Sine of theta equals 5 over 13. And how do you solve that kind? Inverse. To do inverse sine on both sides, I'll do it in red. And these cancel each other, and theta is that. So an inverse sine of 5/13. That's not Q, it's theta, sorry. Theta is equal to, dice of destiny, row 5, person 6, that's going to be you again. No, not you again, that's over here. 22.62, raise your hand if you had 22.62 or so. Okay, good. Now, what I just gave you, all that stuff, I could argue that's everything you need to know. But I could also argue that's the easy stuff. That's like the R2 stuff. Why? How were the test problems that you had last time harder? Yes. How to set them up. That's all we really have to do now for the next couple days is practice setting up difficult situations. Okay? Now this one's going to, I think you're going to think it's not too bad. We're going to make a box. If you don't know how to do this to make 3D, I'd say start with a box and then make another box back here and then connect the corners. Actually, that one's solid. On anything that's like behind, you could make a dotted line, and then it sort of gives you that 3D idea. Okay? So there's a guy standing here at the base of this building. Okay? We'll call him Bob. And Larry is standing here in the other corner of that building. Do you get how there could be a right triangle involved? Because this is a building and it's, 90-degree angles all over the place. Now, if I just told you one side, do you think that's possibly enough to get the answer? Now, I'm glad that you have confidence that it might be enough, because sometimes we do that. We say, here's two angles and a side, but just one side, probably not enough. Okay. Like, for instance, if I say this is X and you don't, or no, if I say this is like 10 feet, and maybe you make it 100 feet. If it's a building, 100 feet long that way, this could be anything, and therefore, Larry's distance, I can't tell for sure, right? All right. But if I tell you two sides on this thing, do you get, I would all of a sudden have a whole bunch of information. If I get two sides that are in the same triangle, I can figure out a ton of stuff. Let's see if knowing these two sides, that's 100 and this is 200 feet long. Let's see if that's enough info for you to figure out the distance, the exact distance, the distance to like go through the building from Bob to Larry. Now, just so that we have some common like vernacular or common like terminology, so when you're discussing this with other kids, you can like use the same words. Let's call these points A. No, actually, let's put B where Bob is. That would make more sense, wouldn't it? Let's call this B for where Bob is. L for where Larry is. What other corners do you think might be important that we might use? Point at it. Just which one am I probably going to use a lot? Yeah, lower right over there. Let's call this C. Is there any other triangles that might be involved? The one for the right of Bob, I agree. Let's call that A. We might get away with just that many triangles. Is that enough information? You can't assume after 5 seconds that you don't have enough information. All right, now, I'm not saying that it is enough information, but what I want you to figure out is everything you can figure out from this. I don't need things like in terms of a variable. Then you could figure out anything if you do it in terms of a variable. But I want to know, like, which angles can you figure out? Which sides can you figure out? Sides that don't even exist that you can figure out. But we could call them things like, BA is pretty obvious, but we could call it like CL or CB or AL. Figure out everything that you can, all right? And we'll go from there. I'm going to pause for a second while you figure out every possible side you can. And there's a lot of right triangles. All right, I'm going to pause while you try that. It's bothering me a little bit that the question is not on the board. The question is, what is the distance BL? That's what I want to know. Distance from B to L. A dotted line that's on the inside of the building. If they had to string a wire between them, how long would it be? I'll pause for a second while you continue. All right, how many of you at this point think there's not enough information? Raise your hand if you think there's not enough information. Don't be shy. All right, you are right. There's not enough information. Because what's the wild card that we can't tell, possibly? The height. If we knew the height, then we'd because see, if I can make the height anything right now, then that distance between Bob and Larry changes, right? The higher I make the height, that change is going to change. So I have to tell you that height, otherwise you can't possibly find the question, answer the question. So then, or I could tell you an angle, right? If I told you an angle, then you'd be able to also answer the question. All right, so I'm going to, instead of just telling you a height, because I think that would be a little too easy, I'm going to tell you that the angle of elevation from Bob to Larry, as if he could look up at him, that angle is going to be 45 degrees. Now you have enough information to answer the question. Okay, I need to get going on it, so if you haven't solved it, let's see what you're missing. Do you get that the pink line that I just drew in that goes from B to C was an important line? Because this triangle right here is the key triangle. The one that goes through the building, also from L to C, and also from B to C. Now, if I were you, whenever I found a triangle like that in the middle of a drawing I knew was really important, I'd go off to the side and redraw it, because it gets so messy in there. It gets so complicated. I'm going to BLC out here, and I know some stuff. I know that's 45. Ooh, and that means this has to be the same, right? 1, 1 squared to 2 kind of ratios, right? That helps a lot. All right, so the way I drew it then is kind of off a little bit. Remember, drawings may not be to scale. And this one's 45. Second here. This was 45. Come on, computer, keep up with me. 45, 45. And do we know any of the sides in that pink triangle right away? No, but can you figure out one? Which one can you figure out? Give it a name. BC. BC can be figured out. And it's as simple as this and this and this unknown side here make this black triangle that I'm going to also pull out on the side here. And that one is from B to A to C, and that would be a right angle. And I know those two sides, 100 and 200. And so therefore, I can figure out the third side with just A squared plus B squared equals C squared. Okay. And that side must be square root of 200 squared plus 400 squared, or sorry, 100 squared, sorry. So who figured out that answer? Just save me some time. Square root of something. 223.6. Can anybody verify 223.6? Excellent. 223.6. So then, if this guy's wait a minute, which did I figure out? I just figured out BC. That's the one on the floor here. I better label these. This is dangerous. B, L, C. And BC is the one here that we figured out was 223.6. Do you get, now you have a side and you have an angle and you know everything? Okay. As soon as you have a side and an angle and a right triangle, you could figure out anything. So if I were going to do it, I'd probably, yes, I can figure out that instantaneously because it's the same, because this is a 45, 45, 90. Or I could just use cosine of 45 has to equal 223.6 over x, and then solve that final answer. What did you get for the distance from Bob to Larry? Back corner. One more time. 316.2. Raise your hand if you got 316.2. Awesome. Okay. So it took a little while to see all the triangles and stuff that are connected, right? That's the challenge of these. All right. Next, we got to go back to a Scrappy the dog kind of question, the bearing stuff that some of you guys are terrible at, but it's a great chance to practice it right now. So this one's going to be out in the ocean, and you have two boats. Okay. One of them is going to be sailing this way, and the other one's going to be sailing that way. And the question will be, how far apart are they? Well, what are some things you'd need to know? Well, you need to know, what angle they're sailing at. So I'm going to use a compass rose right there. And I'm going to call this boat A. I'm going to call this boat B. So my question is, would you agree that boats might go at different speeds than each other? Could that be added into the problem to make it more challenging than last time? Otherwise, it'd be the exact same thing as last time. Okay, so let's say that this boat is chugging along at 10 miles per hour. And let's say this boat is going at 30 miles per hour. Now, if this was calculus, we'd probably be doing something about, like, you know, graphing the area as it changes over time. I mean, ours is not that complicated. We just got to figure out, well, if we want to know how far those are, like, how long is this? It's not. It's a speed. How do I change that so that I know how long it is? The time. If I kept it really simple and said that they went for 1 hour, you'd know how long they were? All right. Let's do that. Let's say they go for 1 hour. How far apart are they? Do we have enough information? What's the thing you're missing? All right, so I'll tell you the bearings. This guy went for 1 hour at, what does that look like? I don't know, 15 degrees? True? And this guy went for 1 hour at west-south 20. Sorry, east-south 20? I get my west and east confused. East-south 20, there we go. There's more than one way to do this to figure out how far apart the boats are. I'll pause and give that a try. Okay, so by saying it was 1 hour, it really cleaned it up a lot, because that was 10 and that was 30. But it'd be really handy to know what all these angles are around this. So if this is 15 right here, then I can use math to figure out what that is. I think it was 75. Raise your hand if you had 75 for that. Good. And now how about this little angle right here? Is that the 20? Yes, it is. That is 20. And it's east-south 20. That means he was heading east, but 20 degrees south of that. So yes, that's what east-south 20 is. All right, good. So if that's 20, then how much is this? 70, because they have to add it to 90, right? Okay, do I need all those angles? No, but it's just handy to have them all there. All right, then which ones do I really need? 75 and 20, and that makes a total of 95. And basically, haven't I got this same setup we started the hour with, two sides and an angle in between them? Now, we started by finding the area, and then we also found that distance. So again, you use law of cosines to figure out this distance. Okay. All right. I hope that was fairly easy from there. Let's see what you guys got. Row 5. Person 5. That's you again. Sorry. You're 5 and 6. So. All right. So tell me what law I'm using to figure this out. All right. So you go a squared plus b squared minus 2ab cosine of c plus c squared. The law of cosines is picky. Which one has to go with C? All right, that's the 95. And which side has to then go with that? Yep, the one between A and B, we'll call it AB. And that's right here. And that is unknown, and that's what we're going to figure out is C. So that's all working out properly. All right, so then A and B, they're 10 and 30, doesn't matter which order. I'll take 100 plus 900 minus 2 times 100, and 900, no, wait, 100, sorry, 10. 10 and 30. All messy in there. Solve it all down, take the square root. Give you a second to complete. Anybody verify 32.4? Did it under pressure, so I don't know if that was right. Okay, good. Yes, 32.4. A lot of people got that. It's probably right. Unless, is there a competing answer that has more hands that's right? Do you think there's a different answer that's right? If you think so, say it. That's what we said, 32.4. Okay, all right, so then looks like 32.4 wins. So what was that? Is that the area? Can you imagine that if they were saying these two boats are stretching out a net across this area that soaks up oil? So they've made a big, huge, like, thing on the surface of the water that's going to soak up oil. Can you imagine that being a scenario? And what are they going to probably ask you then? The area of that. Okay. All right. So there's another possibility. And how about we do one last bearing one, and then let's see if you can figure out a bearing back to the original spot. Because a lot of people are terrible at this. Let's try it. We're going to start here at A. And we're going to go at 70 degrees true for 1 mile. And then we're going to go 220 degrees true for 0.5 miles. What is the bearing? Home. Pause for a second while you set that one up. The bearing, we'll call this B, is where they headed. And we want the bearing home to A, as in from B to A. All right, I want you to just start by drawing the picture. Then try to transfer the angles over. Then make sure you label the sides, because you can't do this unless you know how far they went. So include the sides on your triangle. If you can get the drawing even set up right, that's step one. Step two, try to get as many angles as you can, but you can't find all the angles just from this. You have to do some work with either law of cosines or law of sines. You just can't know the angle instantly by transferring them from one spot to the other. All right. See if you can set it up. We're not going to go all the way to solving this one because it'll take too long. Okay, let's see how far you are at this point. $220. 220 is kind of back in the same direction it came from. Maybe not exactly, but so let's figure out exactly. All right, so this says angle 70. Yes, this is 70. I want to make my B 220. Let's figure out exactly where 220 is. 180 plus how much more? Plus 40 more. Was it exactly back in the same direction? No. Let's figure out what angle this was. If I do alternate interiors, I'm going to go across this line right there and make that 70. See how I did that? It's alternate interior angles. The two transversals were here, here. Or sorry, those are two parallel lines. And this one's the transversal across here. So anyway, that's 70. And therefore that's 20. All right. Then, where is this 220? 180 plus 70 more would be 250, so that's too far. 180 plus 40 more, and it heads back that way. But half of a mile, so that's less. So I'm going to go like here. 1 mile, 0.5 of a mile. So if that's 220, it's 180 plus 40 more. That means this little angle right there is 40. That one was 20. That leaves 30 left for that angle. Ooh, that's handy. You know, that angle up there is 30. If you couldn't figure that out, then you'd be missing an important piece. And then the question becomes, how do you get from here? And I said B to A. I screwed up. I meant from the little blue dot here, which I should have called C, back home. This distance. And that bearing. C to A, not B to A. If it was B to A, we could have done it without any more work. We didn't need the lengths of the sides or anything. It would have just been this one right here, but that's not where he is. He's from C right now. Okay, so generally speaking, I would say that it's about 270, but a little less, maybe about 250 to get from C to A. You don't think so? What don't you think? You don't think it's like 250-ish? I'm not saying that's the right answer. I'm ballparking here. You're shaking your head a lot, so I'm wondering what... Okay. Well, is it possible you drew your line too long and then you'd have to go up? See what I'm saying? Okay, that makes a big difference. So make sure you're in proportion. I'm not saying I'm perfect here, but my line's about 1 and then a half. So I'm pretty confident, but I'm not positive because I haven't finished the problem yet. But I'm pretty confident that my answer is between 180 and 270 anyway. Okay, then last step. Here's the key pieces. Do you remember how we can make a triangle here where we know a side and an angle? And then you can make a triangle on the outside where we have a side and an angle. See, here's an angle and here's a side. All right. And then I can make another triangle on the outside here where I know a side and an angle. I'll make it pink. That one, I'd know a side and an angle. Okay, so barring going through the whole thing, there's at least the setup. Just wanted to remind you how bearings work and where they go. But this is similar to the last test that we did. All right, now there's one last topic that I want to talk over. We'll talk that over tomorrow. And that is, do you remember the ambiguous case? Let's say that's unknown. That's what makes it ambiguous. This is, let's say, 10 feet. And let's say there's a little side right here. The question might be, if this is a 25-degree angle, if this was just the right length, it would touch and make a right triangle. You know what I'm saying there? You could be asked to figure out how long is it. Well, it's not hard because you have a right triangle where you know one of the sides and one of the angles. So it's not hard to figure that out. Okay, but what if it isn't a right triangle? Then this can swing a little bit. And if this is a little too long, then we could either put it here, or we could swing it this way to make it work. And you get that those triangles that are resulting, this dotted line one, this is a bigger triangle than the other one. I'll make it in green. This little green triangle is significantly smaller. So that's the ambiguous case kind of question. There's one like that on tonight's homework. Pay especially good attention to it, and then we'll practice that tomorrow. All right, so for tonight's homework, here's what I want you to do. Find this one. This is a really good one. This is a good area question. It took me a while to figure out, like, oh, they're not giving me enough information. And then I realized, oh, they are giving me enough information. Because as soon as I knew that I had 3 sides on a triangle, then that meant I could figure out angles. Once I figured out angles, this, of course, has to do with the circle, which has special properties of the center. And I would have to tell you that is the center of the circle. That isn't just a random spot. The dot there, that must be the center of the circle. All right, so that's one of the questions I'd like you to do. And then there's this day 1 thing here. Remember that they sometimes use, oh, I guess they didn't use the capital A this time, so that's going to be kind of like you would expect to have to draw it. So do number 1. And let's go on to do, there's another word problem in here somewhere. There we go. No, I'm gonna stick with, there's one that I think is a, you know what, I don't think you're going to be ready for that one about the ambiguous case. I'm going to do that with you tomorrow in class. Otherwise, you'll just struggle really bad on that one. So I'm going to give you this one also. If you do those, you'll be well positioned for tomorrow. The one last thing I want to talk about again is that ambiguous case triangle. And I'll assign some more questions that'll be practice. But then tomorrow is the last day, and then the test is Wednesday. Any last questions? When can you get extra help from me? Well, Mondays, obviously past due on that one, because that's today. Tomorrow, no. Tuesdays, they don't have open hours. But Wednesday, during Mass, you could also get help. So since the test isn't until Wednesday, Wednesday could help. Just don't think that you're going to come in and fix all your problems with one visit in the morning. You got to do all your homework, then come in and get help on Wednesday if you want it. Yes? You mean the very first problem? On these, it's just there's a triangle, find the area. All right, for the challenge, circle 1. Yes, it says A, yeah, see? Area of the blue one. Or whatever's not pink. I don't know if that's really blue, but anyway. Okay, that's all I got for you for today.